Welcome to my channel, DNA.12 Education. Hello students, welcome again to my channel, DNA.12 Education. Students, today we are going to discuss a new topic in mathematics, sector and arc of a circle. Mathematics series, sector and arc of a circle, part 1 for IGCSE and IB. Okay, students, before we go to the topic about sector and arc, the first step you have to understand first about properties of circle. Okay, look at the diagram of circle. This is the circle, right? Okay. Let's say this circle, we name circle with center O. Okay. Yeah. This circle has center O and CA is diameter. CA is diameter. CO equal to OA equal to OB. We call that radius. Once again, CO equals to OA equals to OB equal radius. Okay, students, now we got two properties of circles, very important for circle, diameter and radius. Okay, so what is the red color? In a circle, we call this CB is R. CB is R. R is a fraction of circumference. R is a fraction of circumference of a whole circle. These are respect to angle beta. These are respect to angle beta. So what is this? That's the shaded area, right? This shaded area we call sector. So OAB is a sector. Sector is covered by the radius. The sector covered by radius OA, OB, and arc AB. Sector is a fraction of the area of whole circle. Sector is a fraction of a whole circle. Okay, so let's go to the next properties of circle. This sector respect to angle theta. This sector respect to angle theta. So that's why sector is a fraction of a whole circle. Okay, we have a straight line from C to B. In a circle, a straight line CB is called by chord. Straight line CB is called by chord. Chord is a straight line. Chord is covered by arc CB. Chord is covered by arc CB. But CB is a straight line and arc is a fraction of circumference to circle. So arc and chord are different. So what about this one? Yes, this area we call that sector 2 because this area covered by two radius and arc. We call this one sector as well. Okay, students, what about this one? Yeah, that's correct. In a circle, we call this as a segment. Once again, in a circle, we call this one as a segment. So what is segment? Segment is the area covered by chord and arc. Once again, segment is covered by chord and arc. For this segment is covered by chord AD and arc AD. Is it clear to you, everyone? Hopefully this matter clear. Properties of circle. Okay, students, we go to the next topic. Our topic is sector of circle. As I mentioned before, sector is covered by two radius and arc. Okay? Look at the diagram. This is the diagram of a whole circle. Yes, this is sector. Right? This sector is covered by two radius, OA and OB, and arc AB. Sector OAB respect to angle theta. A sector is part of a circle enclosed between two radius. A sector is part of a circle enclosed between two radius. Let's say theta is angle at center. Theta is angle at center. And as we know, 360 degrees is angle of a whole circle. Right? (360 degrees) angle of a whole circle is 1. OAB is a sector. Sector is a part of circle enclosed between two radius. OAB is a fraction of area of a whole circle. OAB is a fraction of area of a whole circle. That's very clear, right? So how to find the formula of sector? Actually, to find the formula of a sector is very easy. By using the ratio technique, theta to 360 degrees, and OAB is a sector to a whole circle, so we can find the area of sector by using the technique that's very commonly in mathematics. You just use the ratio, right? theta to 360 degrees equals sector to the area of a whole circle. By using the cross multiplication, sector is theta over 360 degrees times area of a circle, right? So sector is theta over 360 degrees times phi r squared. As we know, the area of circle is phi r squared. So sector is theta over 360 degrees times phi r squared. Is it correct? Yes, I think that's correct. Okay, students, we go to the next topic. The next topic is arc of circle. Arc of circle. Look at a circle on your screen. It's very simple, right? A circle with center O and radius R. An R is part of a curve. It's a fraction of the circumference of the circle. An R is part of a curve. It is a fraction of the circumference of the circle. We call this one R. Very clear, right? Okay, we name this length is RBC or RCB. RCB respect to angle theta. RCB or RBC respect to angle theta. Theta, angle at center, respect to R. As we know, a whole circle is 360 degrees. 360 degrees, angle of a whole circle. Right? BC is an arc. BC is an arc. R is a fraction of the circumference of the circle. R is a fraction of the circumference of the circle. That's very clear, right? So what is the next technique? How to find the formula of R of circle? That's very easy. By using the same way or the same method how to find the sector, we can apply the technique to find R of circle. Theta to 360 degrees means arc BC to circumference of a circle. So the common technique how to find the arc of the circle by using the ratio. The direct proportional theta to 260 degrees and arc BC to circumference of a circle. And then we can find the formula by using the cross multiplication technique. So arc is 3 over 360 degrees times circumference of circle. Right? Since means circumference of circle is 2 pi r or circumference of circle is pi times diameter, right? You can find the length of r BC is theta over 360 degrees times circumference of circle or 2 pi r. So the arc BC is theta over 360 degrees times 2 pi r. So that's the formula of r of a circle. R is theta over 360 degrees times 2 pi r. Very easy, right, students? Yes, that's very easy to find r of circle. Once again, r is a fraction of the circumference of the circle. Okay, students, to make sure this method is clear to you, how to find sector and r, you'll find several questions to solve. Here, example 1. In the diagram, ABCD is a square of side 3 cm. AC is an arc of the circle with center B. Find the shaded area. AC is an arc of the circle with center B. Find the shaded area. Students, this question is very easy. How to find the shaded area? Okay, students. How many shapes do you find in the picture? How many shapes do you find in the diagram? Correct. There are 2 shapes. The first is square. The square ABCD, right? Square ABCD. That's the first shape. Square ABCD. Right? That's the first shape. And the second shape is a circle. The second shape is a circle, but the circle is a quarter, right? A quarter circle. Right? So students, we have 2 shapes on the diagram, square and a quarter circle. How to imagine that we have a quarter circle? That's very easy. Look at this diagram. The slow motion is very clear. That's correct, right? We call this a quarter circle, right? So ABC is a quarter circle. That's correct, right? Once again, ABCA, ABCA is a quarter circle. Is it clear to everyone? A quarter circle means it has 90 degrees here, right? 90 degrees. Is that right? That's 90 degrees. Okay? So it will satisfy the requirements of a square ABCD, means every single point on ABCD for a square has 90 degrees. Very easy, right? Okay, students, we go to the next step. You're going to solve this question. Students, the area of circle is pi r square. Area of circle is pi r square. So the area of circle is 3.14 times 3 square, because the radius is 3, right? We got the area of a circle is 28.26 centimeters square. 28.26 centimeters square. Okay, now we are talking about sector BAC. As I mentioned before, sector BAC is the quarter of circle, or 90 degrees to 360 degrees. By using the formula, sector BAC is theta over 360 degrees times pi r square, right? Because here is central angle is 90 degrees here, right? So sector BAC means 90 degrees over 360 degrees times pi r square. So it means a quarter times 26.26. This one, right? You just copy this one. So finally, we'll find the sector BAC is 7.065 centimeters square. Sector BAC is 7.065 centimeters square. So what about the shaded area? The shaded area means area of square minus area of sector BAC. So the shaded area is 3 times 3 centimeters square minus the area of sector BAC is 7.065 centimeters square. Finally, we found 1.935 centimeters square. So the shaded area is 1.935 centimeters square. Very easy, right? Okay, students, we go to the next question. We go to example 2. The question is, triangle ABC is an equilateral triangle of side 5 cm. BBC is an arc with center A. Here is D. Here. BDC is an arc with center A. Find A, the perimeter of the segment BCD. B, the area of a segment BCD. Students, this question very easy actually, right? How to identify this triangle? This triangle is an equilateral triangle, so it means here is 60 degrees. Do you agree? 60 degrees. So how to identify this triangle and how to identify the circle? Look at this slow motion. I'll show you. Is it easy, right? So based on the circle, we got information that we have sector A, B, C, right? We have sector A, B, C. How many shapes do you find on the screen? Based on the question, of course. That's correct. There are two shapes. The first shape is triangle ABC. The first is the triangle ABC. And the second is sector, right? Sector ABC. Let's say sector ABDC. Easy, right? Once again, this is the triangle ABC. Is it? And this is the sector ABDC. Is it clear, right? Okay, students, we go to the next. We are going to find the perimeter in the area, right? Okay, the first is you're going to find the perimeter or circumference of circle. Circumference. For the circumference of circle is 2 times 5 times r. 2 times 3.14 times r is 5. We got 31.4 centimeters. Right? The second step is to find the area of circle. Area of circle. The area of circle is 5 times r squared. 3.14 times 5 squared. Students, you can use your calculator to find the area. .14 times 25. We got 78.5 centimeter square. Okay, students. So what's the next? The next is to find the arc and to find the sector. Right? Okay, circumference we'll use it to find the arc. Now is we're going to find the arc BDC. Arc BDC or arc BC is same. The formula is theta over 360 degrees times circumference of circle. So what is angle of center? It's 60 degrees. 60 degrees over 360 degrees times circumference of circle is this one, right? 31.4 centimeters. So it means this one we can cancel, right? 1 over 6 times 31.4 centimeters. We got, okay, you can use a calculator. 31.4 divided by 6. We got 5.23 centimeter. Done. Now what about sector ABDC? Sector ABDC. ABDC, right? The formula is theta over 360 degrees times area of circle. Theta is 60 degrees over 360 degrees times area, this one, right? 78.5 centimeters squared. So it means a 6 times 78.5 centimeters squared. We find 13.08 centimeter square. That's the sector. Okay, students, very easy, right? Okay, the question is the perimeter of the segment BCD. Question A is the perimeter. The perimeter of segment BCD. Okay, students, segment is this one, right? We call this one segment, right? Segment covered by chord BC plus arc BC, right? Segment BCD covered by chord BC, okay, chord BC and arc BC, right? So the perimeter of segment BCD is BC, right, plus CDB or arc CD. Is it clear to you? BC is 6. Sorry, BC is 5. How do you know this BC is 5? Because the information is equilateral triangle. Same. Is it clear to you? So BC is 5 centimeter plus arc CB or arc BDC is 5.23 centimeter. Finally, we got the perimeter of segment BCD is 10.23 centimeter. Very easy, right? Okay, students, now we go to the area segment BCD. Area of segment BCD. Okay. This is the segment, right? Okay, if we construct again this BCD. Is it, right? That's right. This is the segment, right? We call this one segment. And center of angle of center is 60 degrees here. So we can find the area of segment BCD is sector ABDC, sector ABDC minus area of triangle. ABC. Right? Okay, next. Sector ABDC. Already we got the information sector ABDC, this one, right? 13.08 centimeter square minus area of triangle ABC. We can use the sine rule, right? This one. As you know that the area of the triangle ABC by using the sine rule is a half times 5 times 5 times sine 60 degrees. Right? So this is the area of the triangle by using sine rule. A half times, let's say this one is S, this one is S, right? S times sine theta. This one. You still remember? Formula, right? Okay, next. So sector ABDC is 13.08 centimeter square minus area of the triangle is 10.83 centimeter square. So finally, we find the final answer. $13.08 minus 10.83. We got the studied area is 2.25 centimeter square. Done. Very easy, right? How to find the perimeter of segment BCD and the area of segment BCD. Very easy. Okay, so then we go to the next question. Example 3. Okay. In the diagram, O is the center of the circle. Angle AOB is 45 degrees and the area of the sector OAPB is 30 centimeters squared. Find the area of the sector OAQB and find the radius of the circle. Students, this question is very easy. Okay? How to find radius and how to find sector OAQB. Okay, the first step we are going to find the sector OAPB. That's the first step. Sector OAPB is theta over 360 degrees times circumference of a circle, right? Okay, students, the first step, find the, sorry, not circumference, sorry, that's the area. Okay, sector is theta over 360 degrees times area of circle. Okay. Now we're going to find the area of circle. Area of circle. The area of circle is 5 times r squared, right? The radius. Okay. As we know, the sector of the area OAPB is sector OAPB, based on the question, is 30 centimeters square, right? This one. Is it? 30 equal, theta is 45 degrees over 360 degrees times the area is 5 times r squared. Can you cancel this one? 1/8. Right. So 30 equal 1/8 times 3.14 times r squared. So using the cross multiplication, 30 times 8 equal 3.14 times r squared. 240 equal 3.14 times r squared. So we got r squared equal 240 over 3.14. So r equal, you can use your calculator please. Okay. Root of 240 divided by 3.14. You got the answer, the radius root 140 divided by 3.14. We got 8.74 centimeters. Once again, yes, 8.74 centimeters. We got the radius. Okay, good. Next, we got already the radius of circle is 8.74 centimeters. Now the area of sector OAQB. Okay, students, we can find the angle of OAQB, right? One. Yes. OA, and then around the circle, right? QB, and then back again to O. We call that sector OAQB, right? So what about the angle that covered by OAQB? That's very easy, right? Yeah. So here is 360 degrees minus 45 degrees, right? So we got 315 degrees. Very easy, right? Negative. So here is 315. 315 degrees. Okay, to find the sector OAQB, that's very easy, right? Sector OAQB it has the angle 315, right? And sector OBPA, it has 45 degrees, right? Students, this question is very easy. We can use the familiar technique or method how to find the unknown. What is it? Correct. By using the ratio, right? Sector OAQB over sector OBPA equal 315 degrees over 45 degrees. Very easy, right? Okay. Sector OAQB over sector OBPA is 30 centimeters square, right? Equal 315 degrees over 45 degrees. Very easy, right? So what's the next? The next is cross multiplication, right? Okay, we can simplify first this one. 1 and 7. Yes? Both terms is divided by 45 degrees. Okay, the next is cross multiplication. Sector OAQB is 7 times 30 centimeters square. Right? So the sector of OAQB is 210 centimeter square. That's a very simple one. This is the answer of question A, and this is the answer of question B. So is it right? Yes. Hopefully this matter is very clear to you about the sector and arc of a circle. Good luck, everyone.